screen is visible.
Okay. Let me know when to start.
You can start this session, ma'am. No problem.
Okay. Just 1 minute. Okay. Good afternoon, everyone. So today my topic is little bit, on the smart cities and urban analytics. So we will be seeing like how we can, leverage AI for smart cities and how urban analytics can help in, solving problems. So let's start the session for today. So my agenda will be to, give an overview of what is smart city, like what are the current problems, what is the global and geopolitical trends and investments which are going on and around smart cities, role of AI in smart cities, how the data collection is being done, in different problems, geospatial data analysis. So this I will be showing, a Jupyter notebook file wherein I will be showing a demonstration of how to, analyze geospatial data specifically. Before that, I will be showing you a case study, a live case study basically of my own project, which I have done in last year, city surveillance system. And there are some challenges and considerations as well. So before starting today's session, let me give you a brief introduction about myself. So I am an applied data scientist and research scholar for around 17 plus years of experience. I have started my career as a software engineer and then kind of, led the major digital transformation projects, starting from complex automation and transformation solutions to AI, ML, analytics, robotics process automation, and also have worked in 3D space like AR, VR, and even blending of different technologies. So I am also a doctoral researcher now. Currently, my topic of study is the same which I'm presenting today, that is smart cities. And also, like I have written a couple of white papers which were acclaimed and recognized. Apart from this, like the very least known fact about me is I am also off-road biker. In 2016, I have completed my Ladakh trip in my bullet, and so my only passion is to love. Like I am loving to code. I am very much passionate about coding, and also like adventures. So this is about me. So let's start today's session. You can follow me in LinkedIn. So my LinkedIn profile link is given over here. And so anyone who wants to, interested to connect to me can connect me in LinkedIn. Just 1 minute. Can you tell me like how to little bit, minimize this panel somehow? Can you guide me on this? If you can guide me on this, somebody, to minimize this panel basically. Okay, yeah, I got it. Okay, so starting with the smart city introduction. So if you can see this graph, and also I have put some pointers, like by 2050, the United Nations predicts that around 68% of the global population will reside in urban areas. So that is kind of rapid pace of urbanization. Urban cities are significant contributors to climate change, accounting for 54% of world's population and staggering around 70% of total greenhouse gas emissions. So there are major problems which are faced by cities today, like natural disasters, pandemics, then like effective disaster control mechanisms. Of course, the like the quality air, water, even the like the sewage management. So there are major problems which are faced by cities today. Okay, so that actually like basically aimed to like what can be done better to make these cities more dwellable, kind of like give a quality living to the people. Okay, so if you see this graph also, like it is based on some countries like North America, Latin America, Europe, like continents basically, that how there is a major increase in the world population who are now living in the cities. Okay, so if you see the worldwide graph is telling that around 66% will be there, like the people who will be like moving to the urban areas by 2050. So this is the graph which is like taken from the United Nations. Okay, so these are some global trends on urbanization. So if you see here, like by 1980, only 39% of the people were living in cities. And now if you see in 2015, around 1 minute, sorry. Yeah, around 3.54% of the people are living in cities, and by 2050 it is predicted around 66% of the people will be living in cities, urban areas. And there is some divisions, like the numbers given as per the continent also. So you can see the highest is being seen in the North America, 82%, Latin America 80%, followed by Europe 74%, Asia 48%, North Africa 52%, Sub-Saharan Africa 38%, and Australia 71%. So this is kind of how the people, like the increase in the current trend in living, like the people moving towards the city. Okay, so that is a need of urbanization which is growing recently. Okay, so if you see here that 90% of the urbanization in 2050 that is predicted will take place in Africa and Asia. So that is a major urbanization which will take place. Like if you see in the developing nations, mainly like India and Nigeria, you can see like the major changes or the major transformation is going around. Okay, and also there is China. So share of urban population of all continents. So this actually I have given you the numbers also in the previous table. So these are kind of the trends which are going on currently. Okay, so apart from this, like as the like the urbanization is increasing, basically the greenhouse gas emission is also increasing, and kind of urban areas are contributing 70% of the greenhouse gas emission, which is playing a significant role in climate change, like global warming and everything. So managing cities environmental impact is crucial as the global population grows, necessitating innovative solutions, smart urban planning for sustainable development. So if you see here, like how the places or the countries or the cities are contributing to the greenhouse gas emissions. So these bubbles are actually telling, the size of the bubbles are telling that how much greenhouse gas emissions, like as per the like are coming from the different countries. Okay, so these are like the some global statistics which I have taken. Okay, so there are some important factors around smart cities. Cities must ensure the fulfillment of basic needs. So that is a essential needs which a city should fulfill. That is food, water, shelter, clean energy for all residents. Issues faced by cities include resource management, inequality, technology gaps, social divides, and of course there are government challenges. Investment in smart city has been increasing globally, like with spending projected to around, it will exceed around 1 trillion by 2025. So it is a huge investment and an untapped market, indicating a significant shift towards the technology-enabled smart cities. The adoption of technology in smart city presents both opportunities and risks, including improved risk management through data analytics, automation, predictive analytics, real-time monitoring, and blockchain technology. So basically now the solutions which we are seeing in the smart cities are basically, like blended with AI, IoT, and blockchain to give it a, like a more predictive, result-oriented solution, so that before any incident is happening, the model or the solution will be able to, like predict that and can take necessary actions, can mitigate that risk. So that is the, like the solution which is going around the smart cities now currently. So the convergence of this technology, also AI, IoT, and blockchain in smart cities, offers tremendous benefits, but also requires careful risk assessment. But they also have their own risk. Like AI, there are a certain number of challenges involved. Like we need data, like a large number of data to train the model. And the data should be clean. The data should be proper. Basically, lots of investment is going around AI, and the same with, like the other areas like IoT and blockchain. So IoTs are basically, like a sensors device where the data is coming into the system. So those sensors needs maintenance, and so there are different risk management associated with these technologies as well. So it is, both actually, like advantages of having these technologies, and also there are some disadvantages which can be mitigated with proper, like if it is taken care properly. Okay. So what are the roles of AI in smart cities? Okay, so if you see the major, like I have broken down into major challenges, or the major use cases which can be seen, like where AI has a tremendous role. So one is traffic optimization. So if you see, like for any current city, there is a, like the challenge of traffic congestion, and management is facing some challenges like how to manage this traffic congestion. So traffic for flow analysis using AI algorithm, predictive modeling for traffic pattern, real-time traffic management systems. So smart traffic light adjust timing based on real-time traffic flow data, reducing congestion and improve traffic flow. So these can be fully AI, automated, so that we have the smart traffic lights which can give you warning or the timings based on the real time traffic data to, like manage the congestion. Then another problem is energy optimization. I hope that many of you have heard about the term smart grid. So now government is investing much on the smart grid to basically, like to track the energy consumption. So smart grid is nothing but, like it's a digital equipment wherein it can track the energy coming from various sources and how it is being consumed, like how it is, like consumed in the household and the other industries and factories. So they are actually, like government have that real-time monitoring system, that how they can better utilize the energies using the smart grid technology. So this is also a, like a solution which is given to the, like the urbanization now, like the development of the smart cities. So AI has a tremendous role in development of this, like monitoring system, doing the predictions, like predictive energy distribution, how energy can be distributed and consumed. So there the AI has a major role. Then the waste management. So for the efficient waste management and recycling challenges, definitely we have this challenge in our cities and even in our, like colonies or the, like households. So if there is a sensor based waste collection and routing optimization. Okay, so we can have a, like the AI automated, or AI, we can leverage AI to, like develop a sensor based waste collection and routing optimization, predict waste generation modeling, optimize of recycling process using AI algorithms. Even we can spot the garbages, like with the drone images and the satellite images, like where the garbages are collected and take, like necessary actions, uh, like recording those latitude and longitude where the garbage is detected and giving it to the closest municipal areas basically, or the offices or their CRM system. So lots of, like AI solutions are getting developed to for the garbage detection, for, like automating the waste collection and the management. Public safety and security, of course, we know like lots of video security, video analytics solutions are going on recently, like wherein actually you have like, like any anomaly is seen in the recorded in the camera or the video is taken care of. like surveillance system. Okay, like any, like someone is, like roaming with the, say, a weapon. So that is kind of detected in the camera and can take, like can actually, like warn the stakeholders, the nearest police stations, or the some, like the stakeholders who are there, and can take necessary actions like against that person, or to see at least what is happening. Okay, so not lots of, like things can be controlled using this video analytics. Then the camera images, basically analyzing the camera images, so any anomaly which is coming in the data, that can be sensed and can be predicted. So there are actually lots of work going on the public safety and security. Okay. Okay, so next is water management. There are many actually problems which are there, like air quality. Then I talked about the garbage, basically sewage control. Then water management is one of the problem. Like, like we have the, now we are facing the shortage of drinking water. So water consumption and, like tracking, real time tracking of the water. Like how the water is, the sources of water, and how they are, like getting consumed. And if there any leak detection is, like any leak is detected anywhere. Okay, so those kind of, like sensory, like use leveraging the sensory technology. If you can put AI models into that to understand that where the anomaly is coming, then it can be controlled. Even like supplying, like predicting the supply of the water management, water supply, basically. So those kind of things can be handled with the AI. Supply chain management, so this is actually a tremendous, like the, what to say, this is kind of seeing the immense use cases in, like in the AI, in supply chain management, where you can forecast the demand and supply, and thus you can handle the inventory management, basically the inventory control. Even we are leveraging blockchain with AI in supply chain and optimization to optimize the payment system, basically with smart contracts. Like if the good is received in the like by the, like the receiver, then the payment is automatically made without any intervention, human intervention. So all those things can be, like handled by blending lots of other technology as well. But yeah, AI has seen a tremendous, like leverage in this area. So this is another area like where AI is, like these are some of the areas basically where AI has these use cases. So let's see like how data sources and collections, like how we know, like we can collect the data for the different problem management. So for the traffic management, the majority of the data is coming from the traffic cameras, the sensors, okay, in the roads, the GPS data from the vehicles. So from there, actually from those real time video or the image feeds, vehicle tracking system and all these things, the majority of the data is collected. Then energy optimization, again the data is can be collected from the smart grid, smart meters in the building, energy consumption sensors, weather data. So from there, actually, like the huge number of data can be collected and pre-processed for model training. Then emergency response, of course the cameras, the smoke detections, the motion sensors. So all these, like other data sources, basically where the data can be collected for any emergency response for the public safety and security. Citizen services, so IoT devices, any kind of IoT devices, any social media platform feedback, like customer feedback, usage analytics, sentiment analysis can be done on those feedbacks. So there actually you can get lots of, like data which can be actually, like used or leveraged to train AI model to give the better services to the citizens. So these are some of the data collection techniques. So going forward, I will be putting a case study actually where I have worked myself, and this is very interesting. So let's see that. Any questions so far? Just put that in the chat. Okay, can I go ahead? Okay, cool. Okay, so this is actually a real-time case study which I have worked in last year, and it is a government project basically, not in India but in outside abroad. So let me just explain you the problem statement. So the problem is such that they are like ought to detect the potholes and the garbage for a smart city from the satellite images. Okay, and those detection should be like raised in form of tickets, like the system has to create tickets in the CRM system of their municipal. So the municipal who is falling closest to that proximity, like kind of like from the image, actually we have to detect the latitude and longitude and kind of like create the ticket to the municipal CRM system, which is closest or falling in that areas or in that zone. Okay, so pothole and garbages can be major issues in the cities, leading to safety hazards, environment problems, and inconvenience for residents. Detecting and addressing these issues in a timely manner is crucial for maintaining a clean and safe city. So I think we in India also we have this problem, and it actually like increases in the rainy season, where it is very difficult to detect that where the pothole is when it is filled with water, and kind of it leads to so many accidents, road accidents. So it is a like a very major area where to build a city surveillance system from the satellite images and the drone images, and kind of detecting this pothole and garbages, any garbages if any collected in near the household or anywhere, and can be like raise these concerns in the just like in no time basically, so that people come and like work on those concerns. So this is a major statement, problem statement which I have worked, and so I thought that I will share it today. So the data which was coming was the satellite images and the drone images. Okay, so the solution involves collecting and pre-processing those sub-meter resolution images, satellite images, extracting relevant features, taking a probabilistic model and integrating with the CRM system. So that is kind of the solution gist what we need to build for this smart city. Okay, and what this solution can help improve the maintenance, cleanliness of the city, and provide valuable insights for decision making. So definitely the primary area of the solution was to detect the potholes and garbage. But nonetheless, not only that, the solution was actually like recommending, like we have built a solution which was recommending further more than that. It was actually like detecting the length, breadth, and depth of the pothole. Okay, and kind of like it was detecting the material needed, like how much material needed to fill that pothole, and what kind of material needed, depending on the weather. Like if it's a rainy season, then what should be the mix of the material, and if it is a summer season, then what is the mix of the material. So it is kind of like gone deeper into that and was predicting those kind of things. And so that like and it is still in the monitoring phase, like people are like testing like what AI is predicting. The people are actually the municipal people, the government people are testing that, going live to the site and seeing that whether these predictions are correct or not. Okay, so going further into this problem, so the data collection, as I say, the data collect was a sub-meter resolution satellite images of the city from the reliable source. So it is from the government source only where the images are coming, and the images should have sufficient resolution. So that is kind of like the pre requirements for those images, that should have sufficient resolution to detect potholes and garbage. Check on the factors of data engineering. So see, now when we are talking about data collection. So data collection, and then actually the data engineering thing follows, like what is the frequency of getting those data, how we can store those data, how we can clean those data, what is the pipelining, like the mechanism which will be following in the cloud server. So all these things we have to determine post we know that how the data is getting collected, then how we can like design the entire data engineering thing, starting from data sourcing to data actually like supplying to the AI model basically. So cleaning of the data pipelining, the setting the frequency of getting the data. So everything is like happening post that. Okay, so there is a major design like with the data over here. So going forward, now, this is a high level steps of how data is pre-processed. And I am telling you this on the live case, which I have, like walked into. These are the high level steps, and there are actually granular levels, but I'm just discussing the high level steps so that it doesn't go very technical, but yeah, everyone can understand it. So getting polygon coordinates. Now, what is polygon coordinates? Remember it. I will come to it. Like what is a polygon coordinates of the object or data annotations? I will come to it when I will show you a real geospatial data, like how what is a polygon and multi-polygon coordinates. Okay, so first step is to get the polygon coordinates of those images or the data, pre-processing the shape of the object using the boundary coordinates. So these are the steps, like how we can like capture basically the potholes and the garbages, like detailed, basically the processing steps of it. Then data capturing, Sentinel 2A, that is a satellite actually data for processing. So this is a satellite which was like working and sending the images. So data capturing, how the images are getting captured and processed, and like we are actually pipeline into a system and then we are processing it. So that data is coming. And then data processing and generating NDVI, SAVI, SIPI, and EVI images. So these are basically like all kind of what I said, the different features of image processing basically. So there is a full form of these things. I have written it down. Anybody interested, I can send it. So NDVI is normalized different vegetation index, soil adjusted vegetation index, structure insensitive pigment index, and enhanced vegetation index. So these are all kind of like different layers of data actually, that as or the images used in the image processing. So how we are processing those images. Okay, so let me just put it in the slide mode. Okay, then clipping of the shape file of the geotagged fields, and then generating color coded images with improved image quality. So these are the different steps of the data processing of the images which are coming from satellites and the drones. So basically this is how the data is getting processed, like step by step. Okay, next level is, now in this data processing steps also there are various challenges. Okay, so what are the challenges seen? We have to filter a lot of times, like the do put some filter to get the image clear. So that is image filtering, and these are all the steps of like image processing or computer vision steps basically. So we have to do lots of these things to clear our data, clean our data basically. Now if you see the difference, the filtered before filter and after filter, so this image is much clear. Then this is the original image. See, the brightness is less, and here the brightness and contrast is actually adjusted. So this is the image enhancement techniques which is being put into the data. And post that thresholding. So thresholding means actually separating your original image on which you are interested, that from its background, putting some threshold limit. So basically, if you say that if you are taking a picture of a car and it has a background of a field, so you just want to segregate that picture of the car from the background of the field. So that is the thresholding of the in the image processing. So that is in a simple language I explained. Okay. So how annotation is being done. After that, post this, actually data annotation is done. So once I enhance the image, then I have to like put some image annotations basically of the satellite images. Now it is very interesting how this annotation is done. Now annotation means you are labeling each and every thing in the image, and it is a human task basically. So once because like we are doing it kind of like, and we can actually train a model that how it is being done. So once you are doing it and you know that what kind of images are coming, then basically you can automate that task with the human oversight. So a human can check, like say 70% automation is done, 80% it is accurate, then a human can check whether the automations are correct or not. But till that time, the human intervention is needed to automate or annotate the images, each images. Basically, you have to check on the image and you have to tell the label it. Say, suppose this is a perfect example. So you can see a man riding the elephant, and kind of it is kind of a label, a red shirt of the man, elephant is standing, elephant is brown, roof of the building. So you are actually labeling each and every points in this data. Okay, so this is kind of called this annotation or image annotating. Okay, so this is a very this is actually a very like lengthy step to do, and it takes time and it takes human intervention. So this has to be done to feed to the AI to make it understand that what kind of data it is. Okay, now talking about the geospatial data. So primarily these geospatial data are basically, like coming in latitude, longitude, and all the basically, like I will show one geospatial how it comes, basically the data, how it, one data I will show you of a country, world map basically. So there actually we have a software called QGIS. Okay, so and it helps actually, like most of the times layering of the data, like putting the layers on the data, then like detecting the data, basically like feeding the data and then detecting the data, reducing the noise from the data. So all these features you can see are the, like the features of this software basically. So it can actually, like tag the potholes in the data, basically seeing the, like when you feed the data into the system, it can actually tag the pothole, like they based on some parameters and the factors you provide there. So you can see like view data, explore data, and compose maps, create, edit, manage, and export data, analyze data, publish maps. So these are all the features of this software. So all these things the software can do basically. So after we, like clean the data, annotate the data, then we, like feed this data into the QGIS system to do further tagging of the necessary things. Okay. So post that actually comes the model selection. So since we are talking about images, so ANN won't work here, artificial neural network. I think the people, yeah, because you are from the AI department. So for whenever we talk about image processing, we talk about CNN, convolution neural network, and there are reasons behind it, because the number of, like the pixels which are generated from those images will be very high in number, and that will be leading to very complex computation if we are doing the model, like training with the ANN. So the probable, like the model selection is CNN only. So we will be going with CNN, wherein we can, like feed the images, and actually we can, like train the model with the different, like images, and putting different tags into it, labels into it. So CNN is the best way to do the, like the image processing. On the other hand, PNN is also there, but for this purpose, we have used CNN only, convolution neural network, and wherein we have, like done it very decently, classifying and clustering the images. Okay, so I know that people knows about CNN, like, so I'm not going into detail of it. So there are lots of filtering which is being done, then convolution is put, and then we have to put the activation functions, ReLU, and then kind of pool the, like do the max pooling and all, till we feed that into the normal neural network. So that, like to reduce the image, basically the number of neural network nodes, the input layers and the hidden layers, so reduce the computation. So lots of these things done, and then, like the what we get ultimately in the output can be, like the multi-level predictions or the levels, which detects that whether it's a bare land, or it's a building, or a dense vegetation, or a grassland, or paved road, shadow, water, whatever. So based on our, like images which is being feed into the CNN model, and based on that, the we get this kind of prediction of the levels, like where this what this image is all about. So whether it's a image of a bare land, or there's a building, or there's a dense vegetation. So based on the image quality and what the image is all about, the annotation data and the labels basically which is put into the system. So based on that, it detects all this, the major classification of the image. So on this, actually, we get the pothole or garbage detection as well. So that is also our output, one of the outputs. So now the computer vision steps. Okay, so basically, like when we get the images, so how the model is trained basically. So these are the basic computer vision solution steps. So when we get the image, we need to, like detect the region of interest. So in this case, it is potholes, okay, or the garbages. So we will ignore the other things from the image. This will reduce the false positives. So detecting potholes model will depend on requirement, if only coordinates is needed, or shape or shape information is also needed. So basically, if you see this image, and if this image is fed into, so our region of interest is only this area, that is this pothole. And so we are detecting, like ignoring everything else. We are just, like concentrating or kind of annotating only this part. So our region of interest is only this pothole. Okay. So then the next follows is semantic segmentation algorithms based on CNN can be used to filter the roads pixels. Okay. So if you see that this is an image and putting some, like as I mentioned, like the normal convolution technique, how it happens, the filtering, putting the ReLU, the pooling, upsampling, and softmax. So all these filtering techniques and the convolution techniques. So this is the output segmentation basically. So it is a kind of semantic segmentation algorithms uh, is worked upon, okay, which can also use to filter the road pixel. So like it is used actually to filter the road pixel, so put some filtering and enhancing the images. Okay. So now these are the some common problems. So when we are talking about the images, now what can happen, and these are the common problems which we have faced in while developing this solution or this training this model. So one common problem is occlusion. What is occlusion? Occlusion is that, like, it is like when you are taking that image, like in that sensor, that particular thing is covered. Okay, so let's say the pothole can get covered by a car, or the person is standing just in front of it. Okay, so when the drone is or the satellite is taking the image, that particular place is covered by something. Okay, so the problem statement, like how to solve that problem. So you have to actually go a little bit ahead and little bit previous slices you have to see, wherein you can track like all the vehicles, persons, like how they are moving and all, to get more information about the scene. So little, this is little bit complex, but this is one of the common problems which happens. Like if there is a pothole or garbage and some car is standing just on top of it, so you cannot get the like the detect it. So you have to see the previous slide, like till the car has reached the spot, or the next images maybe to track or monitor to solve this problem. So one image actually like tracked hundred of times before it is sure that okay, it's a original, like originally there is a problem of occlusion or there is no problem of occlusion. So this is a major problem. Another problem is like the different lighting thing. Okay, so if you see that, I have given some example. This is the original image, and this is some like when the rain is happening. This is a snow when it is snowy. Okay, this is like when the like some sun flare has come, then the foggy situation or some random shadow, some shadowy situation has come. So these kind of problems can happen, like different light conditions, weather, water, or something can be on the road. To tackle these, augmentations are used to make the model more robust. So these are some of the problems or the challenges which are faced, like while we are like processing the satellite or the drone images for a city, or to build a city surveillance system. So these are some of the like the very common problems, but this can be solved with more augmentation, and as I said, like tracking actually the image, previous slides and the next slides, to see like how like the vehicles are moving and all. So this is also like this is discussed. Okay, so now the thing is that the training, evaluation, and deployment. So this is common for all the all the AI, like how the AI model is trained and deployed and then tested with the real data. So this is the kind of like the normal steps to be followed. So once we have selected the model, we can train it with the pre-processed and labeled dataset using appropriate algorithm. So that is the first thing. Like we have now processed our dataset, we have cleaned our images, enhanced, done augmentation and everything. We have selected our model also. Then we feed our data to the model, and kind of then once the training is done, we deploy the model, and then we test it on the real dataset. So this is the normal process which takes place for any AI solution. Okay. Now, while doing this, now there are lots of other things or other challenges or risk identification and management sort of area is there, wherein we have to see like what are the other challenges or other compliances we have to see. Now, many of you know that there are like data sensitivity problem in many countries, and they are very strict about it. So they have their own data law. So data privacy and security is a major aspect. So we have to really like encrypt the data while it is in transit, kind of in, or it is in rest. So kind of like we have to encrypt data in transit or rest. We have to do access control mechanism, like people with definite access only can see this data. Okay, then data minimization actually. So like minimizing the data flow basically, like whatever is required only just put that. So that like these problems can be solved. So there are lots of problems with the client sensitive information and all these things, because these are like the images which are coming from satellite. So these are generic images, but there are lots of information will be there, the client sensitive information. So data privacy and security is the major aspect, like while developing this kind of solution. Okay. Then the accuracy of the model. So basically, like this is a iterative process. So in the first shot, maybe the model is not so much accurate, but while training and again, like validating it, testing it, and again, like putting those feedback back into the model, like tuning the weights and the biases again, and you can, like get the outputs which are very close to the actual output. So use of high quality training data, that is one aspect. Train the model with variety of images, so big data should be there. Validate the model with holdout set. Then you have to validate the model continuously. It's a repetitive process. Retrain the model as necessary, and again you have to retrain it. As I said, that you have to adjust the weights and the biases of the model, and tune the parameters basically, and the hyperparameters, and implement human oversight. So the people like who are dealing with like model training in AI, they know that what is this parameters and hyperparameters. So that like you have to tune that. So there are some weights and biases actually like which are associated with models like neural networks, so that needs to be adjusted. And also the hyperparameters, like number of repetitions you want to like train, or the number of layers, hidden layers you want to put. So those kind of factors again like actually um, can be tuned, basically fine tuned, to get your output as close to your real output. So this is kind of one aspect also. Then there are government compliances. Of course, this project was of one of the government. So I won't take the name of the country, but there were some government compliances which we need to understand, which we need to take care of, and then implement those compliance controls, regulatory audits, obtain necessary approvals, engage government stakeholders. So definitely the government officials are involved in this project. So we have to like need to update or report them on a regular basis. The municipal basically the municipal CRM system is involved in this project. So any potholes or garbage detected, it is kind of, we have to, the model will raise the ticket to the municipal CRM system, wherein they take care of the problem statement then from there on. So it is kind of giving them a warning. See, in this and this place there is a pothole, kindly fix it. So kind of it is giving the zone identification, like the latitude, longitude, and so that the municipal people can take care of those problems. So definitely there are lots of regulatory and the compliances which needs to be handled. So this is a real time thing I am telling, which is like needs to be handled when we are solving any like problems related to smart cities, because it is not only like about not only a simple problem solving, but it is related to lots of other things like compliance and regulatory things, because it is involved with the government and the people. So this is also one of the factor. Then risk associated with CRM integration. So again, the CRM system is the external system, and it is a legacy system. Basically, it was there for a long time, and it is a very old system. So how to like integrate the our model with the CRM system, the APIs which are like there, which they are working on not, or there is any authentication, to implement any backup or recovery procedure, ensure system availability, access control, like how the access control will be given, then monitor the system performance. So all these things are there to be taken care of before like we are integrating the model or the model feedback to the CRM system. So these are the some of the kinds of like challenges or the risks which were identified and managed in the Go. Okay. So availability and reliability of the satellite image, this is also another challenge. Okay, so identify reliable data sources. So in this case, our data was reliable because it is coming from the government satellites only. But only thing is that sometimes the images were not clean, and kind of like we have to do a lot of work on the image processing, basically annotation and image processing, like the some common problems I already told, the quality of the image, basically where the occlusion and other problems were there, augmentation problems, so those things are handled. And then regular data quality assessment is being put, so that like we can see the quality of the data, how the data is coming, and even like a backup recovery and the procedure. So there are all these like identified these challenges, like we had identified these challenges and kind of like worked on it, and how to put the policy, procedures and practices in place, basically, so that like it is kind of like kind of automated, the things are automated. Okay, so on these things, the model has gone beyond its normal task, like to detect the pothole and garbage and report to the CRM system of the municipality. But apart from that, data annotation, which was a manual task, okay, and often takes longer time. That I was actually, like we are working, we still are working on it, like to eventually, like train machine to kind of automate it. But it is not 100% self automation. The human intervention is required, basically, to like to understand that whether the AI has labeled those images correctly or not. So it is not 100% thing, but yes, a little a bit of automation is done, and then a person has to oversee that and kind of confirm it. Okay, then now with the pothole detection, the depth and volume of like the pothole is also like kind of like detected, integrating the AutoGAT tool depending on the nature of the image. So basically seeing the image and like blending with the AutoGAT tool, kind of how much depth the pothole has, and what is the like the height and the dimensions, basically the width of the pothole. So those things are detected, basically. So this is kind of like giving them a extra information to understand that what kind of material is needed and how much material is needed to, or how much manpower is needed to like to work on that. Then random live testing of trained weights by volume of water to test the depth dimension calculated upon a model. So this is a real time thing which is being done, kind of what is AI is predicting, to see that whether the AI is predicting correctly or not on the dimension, to see that actually the water is being used to fill the pothole, to see that whatever depth that has been predicted by AI is correct or not, to see the volume of the water required to fill the pothole. So this is kind of a random testing and done on the random potholes to see that whether that prediction is correct or not. So this is also, like it is very interesting. And most of the times it is correct, like 80%, 85% time is correct. But yeah, like that, it was not that, like we haven't achieved that number in one shot. Like it is kind of, like we have to retrain it and kind of keep on training it and feeding it data. And with that, we have achieve that kind of like approximity. And also like recommending some of the filler material. So these not only like based on the pothole, but also kind of like on the weather detection, like how the weather is, and kind of like seeing the old historical data of the municipal, like how they are feeling or using the materials to fill the potholes. And, doing that, like taking that data into consideration, the model learn to recommend something, like if the weather is like this, and then put a winter mix or summer mix, or something else. So there are different materials which are used by the municipal. So based on that, actually they have, like the model like try to recommend on those like materials to fill the potholes. So this is in short about the case study, and I think it is a very interesting one to discuss here. Any questions so far? The slides is not changing. Are the slides changing, or it is only for you? Hello, can someone confirm? Okay. Okay. Any questions? Okay. So this is the case study which I talked about now. So let me just go to uh, some data, like let's see some, like data where the geospatial analysis can be done. And here is a GitHub link which you guys can also go and, like see the, like take the code also. So you can actually, like take this code, and there is a data actually given. So these are the data which are there, and this is for a world map, basically the world map data. And this is analysis, geospatial analysis, which is done. It's a very nominal analysis, but at least to start with it, you can understand that what are the different type of parameters which are coming in the data. So if you see here, like I have actually, like loaded a data here, and this link I will be sharing. 1 minute. So anybody interested can go and see this. Okay, so if you see here that I have loaded a data file, and you can get this database basically, sorry, the files basically here in the data folder. Okay, so you can see like which file I have loaded here. Okay, and these files actually come in a different, like extensions basically. These are some shape files basically. So geospatial data is not, like a normal file. These are shape files which are also fed into the QGIS system software. Okay, so if you see here, like I am getting this continent name and ISO something A3. But the main important thing is see this geometry part. Okay, so there are multi polygons and there are polygons. So these are nothing but holding the latitude longitude of the place. Okay, so if you plot this, so it is kind of giving a world map. Okay, so the countries dot plot I have just plotted, and it is giving the world map. Now if you see here that why, now the question comes definitely, that why for some data the geometry is multi-polygon, and why for some countries the geometry is polygon. So the answer here is, so if I have just put the names of the country and the geometry, so you can see here that multi-polygon and polygon like this it is coming, right? So if you see the, if you just plot Canada, okay, so I have just put Canada's plot here, and you see for the Canada, actually, if you see here, uh, Canada's data is coming. Okay, so for Canada's data, actually, if you see that it is kind of number of small polygons which are there. Okay, so it's a multi-polygon geometry, basically. But for Tanzania, okay, if I plot, it is kind of a single polygon. So for this matter only, for this country's formation, that how this country is, if it is consisting of many, like small lands like this, so it is kind of a multi-polygon geometry. And if the country is a single land like this, it is a single polygon which is coming. So for this geometry is also differing. Okay, so this is a reason that you will get some multi-polygon and polygonal data. Okay, now number of things you can do over here. So you can see that you can plot the cities. So this is a world map actually. So I have plotted the cities actually. So there is a point geometry. So it will be just plotted in the points. The entire world map is plotted in the points. Okay. Then if you want to plot it on the entire world map, that also you can do. Like it has plotted all the cities in the point geometry. Okay, so like this it is just plotted. Some of the maps are not coming, but definitely you can run this, like download and run this notebook and run it. Okay, then latitude and longitude of the cities I have taken, like geometry.x and geometry.y. So it is giving me all the longitude, all the latitude of the cities. So this is the basic in things, like to start with geospatial data analysis, but there are many things which are there, and to, like to analyze or to explore the data, actually how the data is coming. Okay, then you can actually do some intersection and the union of the data. So I will show you that. Just let me go to that point. So this is kind of each country I have colored with some hues. Okay, so suppose take this plot. Okay, so take this plot, and you will see that there is a two countries basically. So like these two countries are coming, and the river is flowing like this on both the countries. So if you see here, like this is the intersection part. Okay, and this is the like this is a common area basically, we can say. Okay, so you can segregate that common area just putting the intersection, like how these two areas are intersected. So just plot that intersection area. Okay, so this is a common intersection area which is being plotted. Okay, then you can just put the entire section, okay, without any intersection area. So you are just putting the overlay image union. So this is a union image basically. Okay, so it is kind of giving both the areas. Okay, now it is kind of you can put a symmetric difference. So this is a difference, like the intersection area is gone. Now only the two areas, like the distinct areas are showing. Okay, only the difference. So the only this area is showing. So likewise you can plot and get different areas. Okay, and you can put like common call, like if you can put the, you can dissolve the union like the boundaries also, and you can just put it as a whole, like the full entire area. Okay, and even you can plot the river. So I shown you like one river was flowing there, so on both the countries. So you can even plot the river with the line geometry, so that you can put here, plotting the river. So various things actually you can do on this. So this is just like you can put the centroid point, the central point of each areas over here. So these are the some of the various things you can do. You can go through this code. So technically, I'm not going through this code, but this is a code which I have already kept here for your reference. So to start with geospatial analysis, this is how the data, to have a like idea how the data comes, and how to analyze or explore those data. So this is it. So I hope today's session you got some insight. Let me just put the PPT back. If you have any questions, just let me know. Ma'am, how do we decide about the suitability of the particular material? Okay, so this is being decided based on different factors. The factors being, one is their historical data, like what kind of material they are putting at what time of the year. Okay, so that data needs to be present.